Yo, ladies and gentlemen, welcome back to a new video. Today we're going to be talking about a very interesting topic today. We are going to be talking about the Zener Diode today. Yeah, we are going to be using the Zener Diode, and we're going to be explaining how the Zener Diode actually works and also how I actually created electricity using the Zener Diode. Yeah, it's really a long story, but stay to the ending of this video to get great insight and full tutorial. Also, do well to subscribe to my channel. It's never going to take a dime from your bank account. Thank you very much for doing that, and without wasting much time, let's jump into the video. Okay, now first off, let's explain what a Zener diode actually is. Now, unlike other diodes, a Zener diode is actually an electronic component which is actually used in electronic project to allow the flow of current in reverse bias when the breakdown voltage is passed. In other words, it's actually also used in electronic components in the building of voltage regulators and other circuits like that. Now, in this video, we are going to be creating electricity using the Zener diode. In the past, I have seen a lot of videos on YouTube using the Zener diode, using lots of Zener diode to create electricity on some kind of cassette plate, but I really don't believe it. But today, I'm going to be testing it out and actually see if my results are actually real and if we can actually generate electricity using the Zener diode. So here's the video I actually found on YouTube, and this is what I'm actually going to be doing today. Not actually the same, but actually following the same theory and testing it out. Let's just check it out. Now, this video actually looked like a scam video or something like that, but I'm gonna tell you, I'm not gonna lie, this video is not actually a scam. You can actually create electricity when facing light on a Zener diode, like on a glass diode. In other words, on semiconductors. Here's how it works. Okay, now let's start with the basic. Semiconductors. Now, semiconductors are materials that have electrical conductivity between that of the insulator and the conductor. Now, when light hits a certain semiconductor, it can excite the electrons, causing them to move and generate electric current for us. Yep, this is how the Zener diode actually creates electricity for us. Now, this principle is also behind the photovoltaic cells, or am I actually pronouncing it well, and also the solar cells. So this is basically how it actually generates electricity for us as a Zener diode. So we all know that a Zener diode is actually a glass body. It's not actually a black body like a normal standard diode. If all components were actually covered in transparent glasses, it will eventually create electricity because and interfere your circuit. So that is why most electronic components are covered in black, and also the standard diode is actually covered in black. They have their reasons why they cover the Zener diode in a transparent glass, but anyways, this is actually basically how it works. Let's quickly go to the practical aspect and let's create electricity, guys. Okay, now this is how I'm going to be starting off. I'm going to be actually testing the output of one Zener diode connecting to my multimeter in set to millivolts, and actually use the sunlight and actually use a normal lamp and see how much voltage we can generate. I mean, the maximum voltage we can generate from this one Zener diode. Then just we add more Zener diodes together and see how much voltage we have, and actually see if it's actually increasing voltage when we connect all the Zener diode in series, because series is increasing in voltage and parallel connection is increasing in current. So if you want to increase your current, you can connect it in parallel. If you want to increase your voltage, you connect it in series. If you don't know how series or parallel connections are done, I made a full video tutorial for that. Check up below or just click up the link right there. So yeah, okay, we experience around 40-50 millivolts at the output of the Zener diode, testing it with the sunlight, and we experienced around 100 millivolts at the output of the Zener diode, testing it out with a normal lamp. This is actually nice, but anyways, we got our circuit working and we actually create electricity from the Zener diode, which is awesome, and that is our main goal. But what is going to be happening here, we are just going to be adding more diodes together, and let's see if we can sum up the voltage and get a reasonable amount of volt at the output of the Zener diode. So typically what I'm going to be doing here, I'm going to be soldering 18 Zener diode connected in series, and yeah, to join the voltage together. And let's see, if we calculating for 50 millivolts from a 1 Zener diode, connecting 18 together, we will end up having 900 millivolts at the output, which is close to 1 volt, and we can have a good figure and see if we can power a little LED. Yeah, we need to power something. I don't know if it's actually gonna work, but yeah, you know what to do. Stay to the end and do all to subscribe so that you will not miss these kind of educative videos in the next one. So let's quickly go to that. In the soldering process, we are going to be choosing the vero board. We are going to be using this type of green vero board, a 2 times 8 centimeter type of vero board, to make our soldering more educative and more arranged properly. So we are going to spread up the diodes, soldering them connectively in series, and bringing out 2 wires output, which we're going to be connecting to our multimeter eventually, and testing it out, shining light on the very board, and actually shining light on the DIY solar panel, not really actually a solar panel. And let's see if we are right on our instincts and we can be able to generate electricity for this. Let us get to the soldering check. First off, we assemble all the Zener diode in series method. Okay, everything is set. Let's start the soldering. We are going to be using a soldering paste, soldering flux, to rub on the board to make our soldering easy and fine. Okay, we are done with the soldering. Look at this chat. Don't worry about those lines right there. I just use it for connection. And yep, we are done with the soldering. This is really nice, really perfect, and really, am I good? Scale me for 1 to 10 in the comment section below, and I really appreciate that. Let's quickly go to the testing of this Zener Diode DIY solar panel. Okay guys, testing it out with a lamp. Yeah, I'm gonna be testing it out with a lamp, and boom. Yep, you may be wondering, why am I having 0 point something volt at the output of these diode which are connected in series? You know what, I honestly still can't figure out the problem, and I was unable to get the desired voltage which we calculated recently in the video, which we calculated as 900 milliamps. What I'm actually seeing on the multimeter right here is on ununderstandable. So you know what, I still need to go deep to understand the concept on how to connect these diodes together to join their voltage and to make it a solar panel. We'll make a future video on that, but for now, we didn't got the video success, we didn't got the project as a success. But just bear in mind that you can be able to generate electricity using the Zener diode, but in the terms of connecting it together, I'll check that out and I'll let you know. If you really like this video, don't forget to hit the like button, subscribe to the channel if you really like this informative idea and you want more content like this. Thank you very much for watching, and also do hope to support me on Patreon at patreon.com/successfulelectronics for more interesting videos like this, and also creating a GoFundMe account campaign on getting a new device for more improved video resolution. Yeah, if you really want me to post the video which have good resolution, you like my content, you like what I actually do, you can go support me at the GoFundMe, and I will see you in the next one. Peace out.